Hello everyone. We're going to briefly talk about polynomials. And the word polynomial, the Greek's prefix poly, does mean many. And the suffix nomial is also terms. So many terms would be the literal definition. And a term or terms, plural, can be the product of a coefficient and a variable, variables, or just constants. So when we look at the examples I'm going to provide, 9x to the 8th power, you notice the coefficient 9 is being multiplied by x to the 8th power. So together that is a term. Okay? And another example could be a variable to an exponent, like in this case, negative x squared. Terms can be both positive or negative, so it really doesn't matter what the sign is. They can be both. And another example would be 2 times x, or 2x. Okay, a coefficient 2 is being multiplied by a variable x. So when you multiply them, 2 times x is 2x. Okay, and another one could be, again, just a constant. Okay, again, it doesn't matter the sign. A number is a number, right? A constant's a constant. So these would be all examples of terms. Okay, so if I have a polynomial, for example, let's say I had 3x to the 3rd power minus 2x squared plus x minus 10, then all of the terms would be 3x to the 3rd power. Another one would be minus 2x squared. Another one would be a plus x, and then a minus 10. So there are 4 terms here. Okay, there are 4 terms. Okay, and so you can tell how many terms a polynomial has, and they're separated by signs. Okay, so 3x cubed is being separated by a negative sign, and then there's 2x squared. So 3x cubed and 2x squared is being separated by a negative sign. 2x squared and x is being separated by a plus sign, and then x and 10 is being separated by a negative sign. So you have a total of 4 terms, okay, in that polynomial. Okay. The other thing that we should mention is coefficients. Okay. And when you have a coefficient, okay, a coefficient is basically the number in front of the variable. Okay. And we can use the same example that I just gave you in gray. 3x cubed minus 2x squared plus x minus 10. All right. And so, like an example, okay, again, you have, we'll use the same example that I just wrote above, just to keep things consistent. All right. The coefficients would be 3, negative 2. For this one is going to be a plus 1. There's an imaginary 1 next to that x, and then minus 10. So those would be the coefficients. So you have 4 coefficients as well. Okay? So coefficients will equal 3, comma, negative 2, comma, 1, comma, and minus 10 for that polynomial. All right? So identifying the coefficients is pretty straightforward. Okay, you just look at the number to the left of the variable. And if you don't see one, then it's an automatic 1. And then terms, again, are separated by signs. So in this polynomial, you have 4 terms. Okay? All right, so let's go to the next slide. Okay? So if you have negative 11 x to the 3rd power plus 12x squared plus 1/2 x. Okay, you're going to list all the terms. Okay? So what we're going to do is we're going to list all the terms. Okay? List all the terms. All right. And we can do that, okay, by look at the sign separation. So we have minus 11x cubed, and then you notice the next one's being separated by a plus. So the next one would be just, you just list it, 12x squared, comma, 1/2 x. If the term is positive, you don't need to accentuate the plus sign. You can just write 1/2 x. You do not need to write plus 1/2 x. And it goes for the same with 12x squared. You don't need to write plus 12x squared. However, if it is a negative, then we want to include it when you write the term. Okay? So there are actually 3 terms in this polynomial. All right? And now, the next thing I want you to do is list all the coefficients. Okay? And we just look at the numbers to the left of each term. So the first one's going to be a minus 11, comma. The next one would be a plus 12. Again, you don't need the plus sign. And then the next one would be 1/2. So that's going to yield 3 coefficients. Okay? All right, so identifying them is pretty straightforward. Okay? And the next thing we're going to talk about is the degree of a polynomial. And this one is not too bad once you get the hang of it. Okay, the degree of a polynomial refers to the exponent. Okay, so it definitely, whoops, let me just write that a little bit better. Okay, it definitely refers to the exponent. Or power of the term. Okay? And you want to choose the highest exponent. So the way to look at it like this is if we look at some examples, okay, we can say the degree of 8x to the 4th power is 4. Because the exponent 4, okay, would be the highest exponent. It's the only exponent in that term, so it has to be 4. And then instead of writing the degree of all the time, I'm just going to replace it with quotation marks. So the degree of 2x is 1. Because the invisible exponent for 2x, there's an imaginary 1 here. we normally don't write ones for an exponent because it's understood. Just like we normally don't write a coefficient of 1 because it's understood. And the same as writing a denominator over 1. Again, we don't normally do that because it's understood. So, but the degree of this is in fact 1. And then if you have the degree of, let's say, a constant like -7, that's always going to be 0. Okay, so the degree of any constant, which means just a number, will always be 0, and that's always going to be the case. All right? So now, when we do an example for, let's say we had, let's say we want to find the degree of 9x to the 8th power plus 8x to the 7th power minus x squared plus 2x minus 7. So the degree of the degree of this polynomial would in fact be 8, because we look at the highest exponent, 8's going to win. So we can say the degree is 8, because this polynomial has the same variable. There are no other variables to worry about. When there are multiple variables, then we have to do a different approach. This polynomial has just the variable x in it, so we just choose the highest exponent. The highest exponent wins. Okay, and that will be a degree of 8. And when we talk about a degree, it's a little bit more than what I'm saying, what it means. It actually can determine what the graph can look like. It can determine how many possible real solutions, how many complex solutions there are. Okay, so the higher the degree, the more complicated and more difficult these polynomials. So in other words, if I set this equal to 0, it'll be extremely difficult to solve this polynomial. Okay, I'm going to say extremely difficult, but you know, it's going to be a little bit of work. Okay. So the degree can tell you many things. It can tell you the number of solutions and the possible shape of what the graph looks like. So it goes a lot deeper as you advance into mathematics and what the degree is. Okay? But for the simplicity of this assignment, we would just say the degree is 8. So this looks like a very complicated polynomial. If we were to set it equal to 0 and solve it, then it would be a little bit of a process. But there are methods to use that can simplify it, but it still will take a little work. So I just wanted to let you know what a degree is, okay? And then on the next slide, what we have is called the classification of polynomials. Okay. And when you have like one term, for example, 9x to the 8, that's considered one term. And one term is classified as a monomial. And the prefix mono meaning one. Nomial meaning term, so one term. Okay. If you look at this example, that would be two terms, and then we would designate that as a binomial. Bi meaning two. okay? So the prefixes can tell you what the word means, and the suffix as well. And so if you know the prefixes and the suffixes of a root word, then you can identify, literally break down the definition of just about any word. Okay, so it's pretty fascinating how the nomenclature works, but it's pretty, pretty powerful. Okay, so let's say you had negative x squared plus 2x minus 7. That is 3 terms. And then we would classify that as a trinomial, right? The prefix tri meaning 3, like a triangle, meaning 3 angles. Okay, tripod, huh? Three legs. Okay, so prefix tri meaning 3, we have 3 terms, so let's call it trinomial. And if you have a polynomial greater than 3 terms, for example, this one, okay, that is basically classified as 4 or more terms. Okay, so that will just be a polynomial, meaning many terms. So that it becomes more generic once you go 4 and above. Okay, and I guess you could say a quadnomial, but we generally just say anything more than 3, it's a polynomial. If 4 or more terms would be a polynomial, or a multi-term polynomial. Okay? Most of the polynomials you're going to be working with will be monomials, binomials, and trinomials. And sometimes you'll see 4 terms, but the top 3 will be the most frequently used when it comes to solving them. And one way to do it is to set the trinomial or polynomial to 0 and factor it. And that requires a certain skill, and then you can set each factor to 0 and solve for x. Okay, we're going to do that a little bit later in a couple videos down the road. Okay, so that's your classification of polynomials. Okay, and a polynomial is in descending order when the degree of the terms start from the highest to the lowest. So the one in orange that I have here, 9x to the 8th power plus 8x to the 7th power, you notice that the powers are decreasing, and then it's minus x squared, again it's decreasing, and then plus 2x to the 1st power, and then the constant would always be to the right. That is your generic way or standard way of writing a polynomial, is you want the terms to be in order. Now you can have them in any order, okay? It's still technically correct, but the general form, you want to have it from the highest exponent to the lowest, so it's a little bit easier to look at and identify the degree. And the degree of this polynomial would in fact be 8 because you just have one variable x. So you just choose the highest. Okay? So just for like a little piece of information, let's say you had negative 7x to the 5th power plus 5x to the 4th power. Okay. Plus 8x squared, okay, minus x to the 10th power plus 5. And you look at that, that is a multi-term polynomial, right? The degree will be 10 because 10 is the highest exponent. Okay, and if you wanted to write this in your in descending order, then you start with the highest exponent. Okay, let me just fix that. You don't forget the sign. The negative belongs with that x to the 10. The sign always belongs to the term to the right. Okay, so negative x10, and then the second highest exponent would be 5, so it'll be minus 7x to the 5th power. And the third highest exponent would be, in fact, plus 5x to the 4th. The fourth highest exponent would be 8x squared, and then what you have left is the constant, and that should always be last. So either one is acceptable. I like to write it from highest exponent to least. Okay, I'm just so used to doing it that way. But like I said, it's not incorrect if you write it out of order. All right. Let's see. So, and that's it. Okay. So really straightforward. Okay. So, and by the way, the leading coefficient, okay, as a little bit of terminology, the leading coefficient in this case would be a -7. Okay, so -7. And here, there's an imaginary -1. So those are called leading coefficients. And that is the highest exponent. So the leading coefficients will be to the left of the variable of the highest exponent. So the variable x, right, to the left of that is -1, and the highest exponent is 10. So the leading coefficient of that polynomial is -1. The one on top, the highest exponent is 5. So the leading coefficient of that x to the 5 is a -7. So those are examples of leading coefficients. Okay, so now that we have some terminology and what things are in regards to polynomials, okay, we can go ahead and do another video when it comes to classification, or not classification, but adding and subtracting polynomials. So I hope that this lesson was very helpful to you. Okay, and thank you so much for watching, and I'll see you in the next video.